think every day I do get better, even if this doesn't sound like I'm getting better, I am. And so one more day of doing this. Now, sometime on Friday, homework 2, online test 2 will appear. Everything that you need to get done has to get done, obviously, by Sunday. So let's start off by finishing off a type of question that we talked about yesterday. And there's really only 2 in the homework. So here's the first one, or at least a version of it. And we're being asked to find a graph, find the equation of this piecewise graph. Now, it's broken into 3 different categories, 3 different ranges. And we got a green guy over here. That's that guy. We got a red guy in the middle. And we got a purple guy up there. So if you think about it, the color scheme is this guy is the green bit. This middle piece, right, from x is -3 to 3 is that guy. And the piece at the end is that guy. So what we need to do is we need to find out what the equation of each of these 3 lines are and put them in here, here, and here. Let's look at the green one. It's a horizontal line. And that horizontal line is at a position -3. In other words, the y coordinates are all -3. So if you think of f of x also being y equals, this piece of the line is -3. Now the piece in the middle is a straight line, and I'll come back to that. And this piece here at the end is also a straight line, and its y value is always 3. So are we comfortable about the 2 horizontal, -3 and +3? Do they seem reasonably obvious, right? 3, -3. Now the guy in the middle is a straight line, and it starts at -3, which is what that's telling me, and it finishes at 3, which is what that's telling me. So I didn't need to figure that out. It was given. I'm going to put the coordinates of this point in. That guy there is -3, -3, and I'm going to put the point for this one in, and it's 3, 3. And I need to find the equation of this line, and it might be y equals 4x plus 2. Whatever it is, 4x plus 2, if that's the case, that's what I put here. So first thing I'm going to do is get the slope. And for something like this, you could probably get the slope by just adding some extra lines in and getting these 2 lines here to make a nice right angle triangle. And the distance from here to here is called the rise, and that's 1, 2, 3, 4, 5, 6 boxes. And the distance from here to here is the run, which is also 6 boxes. And if you want to get the slope, you take the rise of the line, and you divide it by the run. And in this case, since both of them are 6, the slope is 1. And then you make sure that you got the sign correct. And that is pointing uphill, so it's definitely 1. You then pick a point, any point that you know is on the line. I could pick that point. I could pick that point. In fact, couldn't I pick the origin or any of the other points I like, right? I can pick anything. I'm going to be really boring and pick that one. It doesn't matter which one you pick, you get the same answer. You then use an equation called the point slope equation. And what that does is it'll tell you the equation of any line whose slope is m and who passes through the point x1, y1. And x1 is this guy and y1 is this guy. So I have y take away 3 equals m x take away 3. And m I should replace by 1. So it's y take away 3 is x take away 3. If you add 3 to both sides, you get y equals x. And now I know what goes there. I don't put y equals x in that box. I just put the x part because the y equals is kind of taken care of over here. And that's the end of that one. Now this one here is much messier. But since these guys are given to us, we don't need to worry too much about it. There's a green guy over here. Purple guy here. and the red guy in the middle. Right, the green guy is values of x less than or equal to 1, which is this guy. It's a horizontal line, and that horizontal line is 4, y equals 4. This one here is a horizontal line, and it's always 1. The slope in the middle is a bit trickier. This line here, I need to get its equation. So I'm going to try and figure out what its slope is, and I'm just going to add a couple of extra lines. It's 1, 2, 3 that way, and 1, 2, 3. Oh, that's pretty boring. 3 that way. So the slope is 3 over 3, which is 1, but that's pointing down the way, so the slope is negative 1. I'm then going to choose a point. I'm choosing that one there with coordinates 2, 2. And now I can get the equation of this line. Y take away y1, m, x take away x1. That's going to be x1, that's going to be y1. So y subtract 2 is negative 1, x subtract 2. Y take away 2 is negative x, add 2. Add 2 to both sides. There you go. Negative x, add 4. And it really doesn't matter how complicated the equation of that straight line is. This method of getting the slope and choosing a point and picking the point slope equation works totally fine. Now, they have a third question that looks very similar, but it's not really, because you're not being asked to find the equation of this guy. You're actually just being asked to evaluate, find the numerical value of something. So f of 1, well, there's 1. F of 1 is that guy, and that is 1. F of negative 1 is that guy, negative 1. Now, that's a bit trickier. When they say solve f of x equals 4, think of it as this. Find the values of x, or value if there's only one, such that, and instead of thinking f of x equals 4, think of it as the y coordinate. So think of f of x as being the y coordinate is 4. So what I would do in this question is I would say, okay, if you're going to have a y coordinate of 4, you have to be along here somewhere. Oh, you're here. And what value of x makes that happen? Oh, x equals 4 makes that happen. So when it says solve for f of x equals 4, the answer is x equals 4. Now when they say solve f of x equals negative 4, if I draw this guy along here, the value of x that gives you this fella also happens to be the same number, negative 4. And that's pretty much the end of it, right? Is there any questions about the last 3 questions or anything else from that section before we move on to our next section? Are we good? Okay. Okay, our next section is still in section 2.2, and we're going to look at properties of functions. So, a fair amount of notes are going to happen today. So let's get started with a definition. A function has the property that for every value of x, there can only be one value. One value of f of x. So a formula is a function. It has the property that for every value of x, there can only be one value of f of x. So let's show you what that would look like. This is a function. Looks like that. If you choose any value of x, do you see that you only get one y coordinate, right? One value of f of x. This is a function. Let's look at something that is not a function. That is not a function. And why is it not a function? Well, can you imagine I chose that value of x? Let's say it's 1. Isn't there actually two distinctly different answers, two distinctly different y values? So this is not a function. And we have a very simple test that you can use if you've given a picture of the graph, right? So if someone draws the thing, there's a very simple way of telling, is it a function if it's not? And it's called the vertical line test. And what that says is, if every vertical line crosses the curve at, well, how am I going to phrase that? At one place only, then you have a function. So if I just randomly draw some curves, there's one. There's another one. There's the third one. And there's the last one. So here are some curves. Some of these are functions and some of these are not functions. The vertical line test says you start at one side and you scan crossway. If you only cut the curve once place, no matter where you go, this guy is a function. If you do the vertical line, and can you see that, for example, at this one location here, do you see there's two places? You are not a function. Is this picture here that my finger is pointing at, is this a function? Agreed. Be careful about it. Is this one a function? Well, let's do a vertical line test right here. Can you see that there's going to be a whole load of points all on that same green line? Right, it's vertical. Technically speaking, then, isn't that an infinite number of points with the same x value? So, not a function. Yes, you are a function. So the vertical line test, you scan from left to right. If you cut even one place, only needs to be one bad place, where there's two or more, and here there's an infinite number, you're not a function. If every place you do it, it's only got one piece, You're good to go. It is a function. So let's show you some homework questions. They're pretty easy to do because the answer is yes, it's a function, or no, it's not. First, I have to make sure I've found it, don't I? Yes, I have. So you should be looking at Q2 property functions. Okay. Can I make that bigger? That would be a good idea if I could. Okay, what about that box? Is that a function? Is A, 1A a function? Yeah. Where are the problems? Well, pretty much everywhere, right? If you do a vertical line here, it cuts it twice. If you do a vertical line at the end, isn't it not just heck, it's not a function, it's heck, it's definitely not a function, because at the ends, aren't there an infinite number of places? In question B, if you do the vertical line test, everybody is good. It's a function. Okay. C and D, which one of those two guys is a function? Because only one of them is a function. Someone's typed it in. Let's see if they're right. Correct. If you do a vertical line here, now you might say, well, what's happening at the y-axis? It's okay if there's nothing there. It just can't have two places. Here, dead in the doornail. And here's some more examples. Now, now, once you have a function, one of the things that you very often want to know next is what is the domain of that function and what is the range of that function. Now, in this particular function, do you see that solid dot here and that solid dot there? That's not cosmetic. That basically means the function starts at the left dot and it finishes on the right? That's all there is to this function. So the first thing I'm going to do is a vertical line test. And if I imagine lots of vertical lines, yes, this curve is a function. Agreed? No matter where you draw it, it's only going to cut it once. Now, what would the domain and range look like? Well, interval notation is going to be used. The domain are the usable values of x. So for this function, the first value of x where the function starts is -3, and the final value is 2. And so I'm going to go here, and I'm going to say it starts at -3, and it's going to finish at 2. Why am I using what I call square brackets for the domain? Why is it not curved brackets? Why am I using square brackets? Any suggestions? Why? Okay, here goes. You see that dot there at 3? Doesn't that mean you can use x as -3 and get an answer? And you see this solid dot at 2, doesn't that mean you could use 2 as an answer? Now, if that solid dot was an open circle, that would mean you couldn't use the answer. So if this was an open circle, you do a curved bracket at -3. And if this one here was an open circle, you would do a curved bracket at 2. Now, the second guy that we're going to do is, again from the picture, is the range. And the range is basically the range of y values that you can get here. As I look at this curve, it looks to me like the smallest y value is -3. So that's the lowest the function ever gets to. It looks to me like the highest it ever gets to is 4. And it does reach those values, so we are done. Okay, question 4. Is that a function? Is that curve a function? Have a look at it, guys. Is that a function? Do a vertical line test on it. Does it cut it twice at any place? You see it going down there, it would cut it twice, and over here it would cut it twice. So, no, it is not a function. Agreed? Not a function. Now, if you are not a function, you might think that the thing has a domain, and you might think that it has a range. Well, it has things that are kind of like domain and range, but you only use the terms domain and range when you're talking about a function. So in that case, you put down none for the domain and none for the range. So if you get a question and it's not a function, the domain and range are always going to be called none. Now, you might say, and I can understand that, but look, you can use values from -2 to 2. I agree. And the y values go from -4 to 4. Can I call them domain and range? No. You can make up another name for them and say that the x's are -2 to 2's and the y's are -4 to 4. You can use any term you like, but don't use the words domain and range. They are specifically only used for functions. And if you're not a function, you don't have a domain, none. You don't have a range, none. So I don't feel alone. Hopefully somebody's going to answer this question. It's the same kind of question I've asked before. Is this a function? Shaking your head is good. I'll take that as an answer, Elise. Correct. Do you want to tell other people who are looking why that is not a function? What's the problem?
You put a vertical line down the -3 x value.
And don't you get an infinite number of points, right?
Yeah.
So that's a kind of heck no. You're definitely not a function. And because it's not a function, won't domain and range be none? So in homework questions, aren't things that are not functions very easy homework questions? Because it's no and none and none. You don't even think about it after that. Now this one is a bit trickier. If I do the vertical line test, it cuts it once, it cuts it once, cuts it once, cuts it once. The only problem there might be is at this overlap, right? Now, if I draw a vertical line down here, do you see that it only cuts the curve once at the dot? And because that's an open circle, maybe I'll make that a little bit bigger so we can emphasize the open circle part, right? Do you see it's open? That means this is a function. Now, domain and range are quite difficult for piecewise functions. They're much easier when they're not piecewise. But the domain is going to be usable values of x. So I'm going to start at this value of x here, which is what, -6. And I can get answers all the way to 2. So if I'm talking about the domain, what in the heck are you doing? The answer is -6 to 2. I'm confused. -6, -5, -4, -3, -2, 1, 2, blah, blah, 0, 1. Oh, that's not -6, that's -5. Okay, -5 to 2. I can work with that. There you go, -5 to 2. Now, the range is weirder. The mistake would be to say this, oh, the lowest number is -3 and the biggest number is 4. And for you simply just to say -3 to 4 is a single interval. It's messier than that. Essentially, -3 is an answer, right? It happens quite a lot of times. So it's -3, one of these two. But the other y values, the other answers you get are from 0 to 4, right? This guy is at 0, this guy is at 4. Now, 0 to 4, right, is a whole interval. So I'm going to go down here and I'm going to say, okay, -3 on its own and 0 to 4, -3 on its own, 0 to 4. Why am I picking that second one instead of that top one? So why is it -3 and open 0, closed 4? What in heck is making the 0 a curved bracket and the 4 a square bracket? Any suggestions? Okay. If you look at 4, isn't there a solid dot? Doesn't that mean you can get 4 as an answer? Can you get 0 as an answer? Ah, no, there's a little circle there. That's the reason. So do you see it's getting a little bit more difficult to identify ranges especially. And then we enter a whole bunch of questions which are really quick, which I like. And they are called, am I a function? And the answer is, yes, I am, or no, I'm not. Okay. And how do we find out? Well, the easiest way to do this, and I'm going to move this guy over here a minute so I can do it, is to use Desmos. And problems finding, there we go. So if you bear with me for a few moments, I'll load up Desmos. And here we go. And Desmos. And here is our first guy. I'm going to type in X. This is a question 8. Oops, don't want capitals. X equals y to the power of 6. Right, there it goes. Can you tell using the vertical line test that that is not a function? Now, can you pretend just for a minute that they had a y equals x to the 6? Can you see the blue guy is a function? So the x's and y's do matter, don't they? It depends which one's x, depends on which one is y, right? Even although the formulas look very similar. How about this fella? 7x squared take away y equals 2. Rub that guy out. Oh, function or not a function?
Function.
Function. And it is as easy as that, right? Don't second guess yourself, right? Imagine a lot of vertical lines. It's only going to cut it once. We are good. And how about this one? I'm not sure WebAssign can cope with every situation, but so far it's doing really good. We have an x squared plus a y take away 7 squared. And I'm going to put in a few seconds equals, and I'm going to put a number. And the number I'm going to put is 3. Do you think that guy is going to be a function or not? What's your gut feeling? I see some shaking of heads. And you were right. It's not a function, right? Vertical line test, cut 6 ways. Try one more of these guys. Square root of y. Oh, don't need brackets, do we? Square root of y. Take away x equals also 7. I don't have a problem with that. Would you agree? Vertical line test, it's a function. Great. Vertical lines, cuts it once. So let me close off, bring this guy out. This section I'm doing is, well, we're rapidly going through it, but I don't think it's that difficult to do, especially these later questions, right? Now, can you imagine plugging that into Desmos and coming up with, is it a function or not? So now we are entering a different group of questions. So they're not asking is it a function or not anymore. They're asking us to look at properties of what are called family of functions. So I'm going to nip back and do some notes here. Right. Imagine I have f of x equals x take away c squared. And then I tell you that c can be 0, it can be 1, it can be 2, it can be -1, it can be -2, it can be -3. So I give you a whole list of possible values for c. What you're creating here is called a family of functions. So here we are. If you use nothing, x minus nothing gets you x squared. If you use c equals 1, you get x minus 1 squared. If you put x equals 2, you get that guy squared. And if you put x equals, c I should call it, 3, you get that guy squared. If you plug -1 in, x take away -1 basically makes it add 1. So you get that one. Oops. You get f of x equals x plus 1 squared. Then you get plus 2 squared. And then finally, you get x plus 3 squared. Now, in these questions, what you're meant to do is sketch all of these guys. I would probably use Desmos, but you can certainly do your TI-84 as well. And you go like this. First one, okay, imagine I did it in Desmos and it looked like that. Now, if I sketch this into Desmos, I want you to trust me here, but it looks like this. If I put the next one in, I'll show the colors here, it looks like this guy. If I put in the next one, it looks like that guy. Do you see that what you're basically getting here is the same function? It's just being moved to the right. Move to the right once, move to the right twice, move to the right 3 times. If I put this guy in, do you know that you would get the same function, but move to the left 1, move to the left 2, and move to the left 3? What that allows us to do then is that if we have a family of functions and we know how the basic one works, we can make a pretty intelligent guess at what one of the members of that family looks like. So I'm going to do f of x equals x squared again. And I am going to make a prediction about what that guy would look like. Now, if I put y equals x squared in, it would look something like that, right? What would this guy look like? What would you do to this original red one to get the graph of this guy? What simple movement would you do? Any suggestions?
Move it to the right.
I agree. How much? How many?
5.
5. So 0, 1, 2, 3, 4, 5. And then the only thing that would really be different is its location. It would still look like the same big happy face, right? Let's put that to the test then. I'm going to There we go. I'm going to go in to Desmos, and we are going to put in the original function and the new guy and see what they look like. I'm just going to call them y equals because Desmos behaves better when you call things y equals. There's the original. And here is x take away 5 squared. Now I'm about to hit 2 in a minute. Right? And, well, let's get that equals right before we do that. Right, I'm about to hit 2. Now, if we've done this correctly, shouldn't this shape just appear roughly where the mouse pointer is? 5 to the right. Nailed it, didn't we? 5 to the right. What would this guy look like? And I'm going to change this guy to +2. Do you see all that happens here is it moves to the left 2? If you took that green one, isn't it the exact same shape in every other way? It's just its location is different. And that is a family of functions. Now I'm going to do a different family of functions. I'm going to start off with x squared again. What do you think x squared plus 2 would look like? So there's x squared, right? And I'm just going to put a +2. What do you think the new guy would look like compared to where the green guy is? What would you do to it? X squared plus 2. I have a comment. Let's see what it is. And I agree with you. I believe it's going to move it up 2. And guess what? Does that make sense? Now, if I put in 3, wouldn't it just move it up 3? If I put in 7, it would move it up 7. If I put it up 1, it would move it up 1. What would happen if I said take away 3? Kind of logical, wouldn't it? Add 1, add 2, add 3. What would you do with take away 1, take away 2, take away 3?
Move it down.
And move it down. So take away 3. Do you see how understanding how a family of functions works allows us to do pretty easy sketches of a function, right? I could go to my paper here and draw a sketch of x squared minus 5. And I wouldn't need to do a lot of details. Wouldn't I just do a happy face for x squared and move everybody down 5? That's all I would need to do to sketch that function. So let's put this together and do 2 things at once. Right. Oh, I think I can stop it from, good. Right. What will happen to the x squared? How will you move it to get that guy? So think of combining the 2 things we've done into one. What do you think? That's 2 seconds. Anybody get a shot? Anybody feel brave enough? I hear, or I'm reading, move it up 2, down 2, left 3. Oh, well, you can't do both. That wouldn't be such a good. All right, let's show you. I'll do it in pieces. There. The first piece moves you to the right 2. The second piece moves you up 3. So if we take this guy off, can you see that you move it to the right 2, and then you move it up 3? Do you see that combination? The x minus 2 is move me to the right 2. the +3 in its own means move me up 3. And that's that skill of being able to look at a function starting with x squared and then figuring out what a family of functions movement would look like. Oh, move them up 3, move them to the left 3, or maybe do 2 things, move them to the left and up, that kind of thing as we did here. And that, I think, is a good point for us to finish today. So last name for attendance, and call it good for today.
I have a question.
Sure, what is it, Liz?
So for the Desmos, or not Desmos, WebAssign
Uh-huh,
homework, just for the first one, the 2.1 functions homework,
yes,
I was having a really hard time for the last couple of questions.
gotcha.
Um,
Okay,
The
I'm going to look
difference
at,
quotient.
right, so the difference quotient is a heavy duty algebra question, right? If I recollect. So I'm going to do an example of that, you know, similar, maybe not the same as yours, but enough to give you an idea how to do it.
Okay.
So
I was
what you're
just
gonna-
having a hard time with the ones that where
Mhm.
f of x has a squared in it.
Okay, let's do
and
one with an
the-
f of x squared in it.
Yeah,
So-
and then f(a) plus h, and then f(a) and then h.
Okay, so suppose f of x was this guy, right? Just for argument's sake. Right. Now, the difference quotient is f of a plus h, take away f of a, all over h. That is called the difference quotient. And what we're going to do is for this function, we're going to find f of a plus h. We're going to find f of a, subtract them, divide it by h, and make it as simple as possible, right? Simplify it as much as we can. So first thing I'm going to do is find f of a plus h. Now, the way functions work typically is that you get a number and you replace the x with the number. But you are allowed to, in fact, replace the x with anything. It could be a number, but it doesn't need to be. In this case, that whole piece here, the a plus h, is an x, right? It's going to replace the x's. So you're going to get a plus h squared plus 3 lots of a plus h. Now I'm going to multiply this, collect like terms, do as much as I can to make it pretty. First thing I'm going to do is multiply a plus h by itself. And while I'm at it, I'm going to distribute the 3 to get those two guys. Now, if you FOIL it, you get a squared, you get an ah, you get an ha, and you finally get an h squared. And then tag on these two guys at the end. Are we good so far? Right. Now, these two guys are technically the same thing, right? AH and HA are the same thing. So I'm going to combine those together. And now I have a squared, 2 AHs, plus an h squared, and still tag on those two ugly guys at the end. And that's what f of a plus h is equal to. And I'm going to put a little box around it so I can find it when I need it. Now, the next guy I need to know is f of a. And the same thing is true. You can plug in a number here. You can plug in, instead of x, 42. Instead of x, you can plug in a plus h. Or, as here, instead of x, plug in a. So x becomes a, so it's a squared. X becomes a plus 3a. And that's as good as that's going to get. So I'm finished with that guy. So now I'll put them together and see what we can simplify it down to. So I have f of a plus h, take away f of a, all over h. F of a plus h is all of these terms, none of which combine, unfortunately. take away f of a, which is put brackets around it to make sure that you're taking away both of the pieces. I have a squared plus 2ah plus h squared plus 3a plus 3h. Take away a squared and take away 3a. And then we got lucky. That a squared gets killed there, and that 3a gets killed there. So at least there's some like terms that cancel out. And now I'm going to be left with 2ah plus h squared plus 3h all over h. And I'll pause here. If you do these questions correctly, you will reach a point in your working where the terms on the top all have at least one h in them. If you end up with a piece like a plus 2a or a minus a squared, you've done it wrong. Stop and figure out what went wrong. Now, once you get to this stage, the next thing is you take the top term and you pull out a common factor of h. Right? You pull out a common factor from the top term. That's going to happen all the time. And then you are allowed to cancel. Now you're allowed to cancel those guys. And that leaves us and that's your answer.